So I'm going to start here with a scalene triangle, making sure that all three sides are different lengths. We'll go into isosceles and equilateral later. So to construct the medians first, I'm going to construct the midpoint of each side. And there's a tool for that. Once I get the midpoint of each side, I'm going to connect the midpoints to the vertices across from them using the line. Now to color coordinate so that it all looks uniform. Next, I'll add in the circumcenter by constructing perpendicular bisectors from each side. You have to go clockwise around the figure to get the angle bisector in the right spot. So you'll see I'll click on each vertex and then get an angle bisector. Once I have all three angle bisectors, I will now have the in-center, and I'm going to color coordinate it so it matches. Using the perpendicular line tool through a vertex and a side, I can form the altitudes. All three altitudes gives me the orthocenter, now color coordinated. Watch as I drag the triangle so that I get approximately a right angle. I'm just kind of eyeballing it here. You'll see that the orthocenter ends up on the right angle and the circumcenter ends up on the hypotenuse. This happens in every right triangle. As I drag the triangle to make it an obtuse triangle, both the orthocenter and the circumcenter go outside the triangle. Doing some quick adjustments here, I'm going to turn this into an isosceles triangle just by kind of eyeballing it by putting both points on a circle. Now you'll see that all 4 points of concurrency seem to line up together. In fact, all 4 points of concurrency will fall on top of the altitude that goes from the top vertex to the base. So using my best approximation, and there are more precise ways, I'm going to turn this triangle into an equilateral triangle. Using the second circle, I'll be able to make sure that the distance between all 3 points are roughly the same. And as I pull that point in to make it equilateral, we see that all of the lines start coinciding. That gives us all 4 points of concurrency at the same point in the center, and all 4 sets of lines will join up and essentially become the same line. This happens in every equilateral triangle, no matter how large. Stretching the triangle back out so that it's scalene, I'm going to demonstrate what happens when we put in the circumcircle by putting a circle centered at the circumcenter. The in-circle is centered at the in-center and just touches the triangle on its 3 sides. I'm now going to demonstrate that the circumcenter is equidistant from each vertex. You can see that the 3 segments I just constructed are all an equal length. I can do something similar with the in-center by showing that segments perpendicular to each side are equidistant from the in-center. So to recap, if it's a right triangle, the orthocenter and circumcenter fall on the triangle. If it's obtuse, they fall outside the triangle. In-center and centroid are always inside. If it's isosceles, they all line up on the altitude, and if it's equilateral, they all coincide together.